Hello everybody and welcome. Today we're going to go deeply in a topic we discussed before, which is vectors, okay? So as a quick reminder, first of all, vectors are physical quantities that need a magnitude and a direction to express them. Then we mentioned that forces are forms of vector quantities because they need a magnitude and a direction to describe them. But have we ever asked ourselves, can we add vectors together, or how can we add vectors together? In other words, how is it possible to add a physical quantity that are not going in the same direction? Because we said that vectors need a magnitude and a direction to express them. But what if these vectors were not going in the same direction? That's what we will be answering today. Now, the term adding vectors will be replaced with a better, more scientific term called finding the resultant vector. So we won't say adding vectors anymore. It's not very professional. We will say finding the resultant vector. So if somebody asks you to find the resultant vector, it's like he's telling you to add these vectors. First of all, we're going to start with how to add vectors that are going horizontally or vertically together. Now, in most cases, it's very simple and common sense. For example, look at this box. If somebody asked you to find the resultant force on the box shown right here, it's common sense. You're going to say that the resultant force will be 5 newtons to the right, okay? Let's look at this box. You're going to say directly that the resultant force will be equal to 15 newtons to the right. Now, you already know the fundamentals of finding a resultant force because, as I said, it is common sense. But it's very important that when we describe the force, we describe it by the magnitude and the direction of the force since it's a vector. In other words, if in the first case I said that the resultant is 5 newtons, your answer is not totally correct. You must mention the direction. You must say that it's 5 newtons to the right. That goes for the other question too. It's 15 newtons to the right. You must mention the direction because if you do not mention the direction, your answer is not a full answer. Now, sometimes we just use signs to represent the direction of a vector. You don't always have to write to the left, to the right, upwards, downwards. So it was agreed on if I use a positive sign, it means that I'm going upwards or to the right, okay? And if I used a negative sign before the vector, that means that the vector is either going downward or to the left. To summarize, we just look at this shape. As you can see, to the left and downwards it's negative, to the right and upwards it is positive. Now, how can I add two vectors if they were not going in the same direction? In other words, if they were right angle to each other. Remember first that the word right angle to each other means that the angle between them is 90 degrees. So if the angle between two vectors is 90 degrees, there must be a certain way to deal with it. For example, let's look at this box right here. It has two forces applied on it. One is equal to 4 newtons and one is equal to 3 newtons. And as you can see, the angle between them is 90 degrees. If we imagine it looking like here, we can see that we have 90 degrees between them, okay? How can I add these vectors together? Well, it's very easy. Some of you already know that. The resultant vector is found by using the Pythagorean theorem. In other words, we will just say that FR is equal to the square root of 3 squared plus 4 squared, which is equal to 5 newtons. Now, what's with the FR term? The FR stands for resultant force. Resultant force. And the direction of the force will be between these forces. As you can see, it's common sense. The box will go somewhere between the 4 newtons and the 3 newtons, and it's going to be a little bit closer to the 4 newtons, okay? Now, how can I describe the direction? You mentioned before that a vector needs a magnitude and a direction to describe it. So how can I describe the direction? Well, actually, it's going to be described using something we call the inclination angle. So for inclined vectors, we will need to find something called the inclination angle. But first of all, we will do a quick reminder on some trigonometry. Now, remember that if we have a right angle triangle, we have the adjacent to this angle. Let's say we're studying this angle, angle theta. We have something called the adjacent, we have the opposite, and we have the hypotenuse, okay? Now, First of all, we must keep in mind that the angle theta is the angle between the vector right here and the horizontal line. So it's this angle right here, okay? As a quick reminder, for a right angle triangle, we know that the sine of this angle is going to be equal to the opposite divided by the hypotenuse. The cosine is the adjacent divided by the hypotenuse, and tan will be the opposite divided by the adjacent, okay? That's just a quick reminder. But until now, we did not answer our question. How can I find the angle theta, which is the inclination angle? Well, to do that, we're going to imagine that we have the original vectors. Remember, the original question, it had a 4 going to the right and it had a 3 going upwards. So we can just imagine it like if it were a triangle, right? We have this is the hypotenuse, which is equal to 5. This is the adjacent, which is equal to 4. And this is the opposite, which is equal to 3. How did I know that? Well, look at it right here. We can just continue this triangle right here. This distance here, it's clear that it's equal to this distance right here. So now we have a right angle triangle, and we're trying to find this angle. And we can just use trigonometry as we seen before. It can be said that theta is going to be sine inverse to the opposite divided by the hypotenuse. So in our case, it is very simple. Sine inverse of the opposite is equal to 3, and the hypotenuse is equal to 5. So it's sine inverse 3 divided by 5. Using a calculator, you can just say that the angle is 36, or we can use cosine, which is the adjacent divided by the hypotenuse, and it's going to be equal to 4 divided by 5, or cosine inverse of 4 divided by 5, which is equal to 36 degrees. Okay? Now we found the inclination angle. Let's go a little bit further. Third step. So we learned how to add vectors if they were horizontal or vertical together. Now we also learned how to add vectors if they were right angle to each other. But how can I add vectors if they were not right angle to each other? First of all, we must know that for an inclined vector, I can turn it back to its original components. I can give it an x component and a y component. For any inclined vector, I can turn it back into its original components in the x direction and the y direction. So the x component is going to be the resultant vector, which we already found, multiplied by cosine of the angle. Remember, if we had, let's go back and draw our triangle. We had this triangle, we had this equal to 5, this was equal to 3, and this was equal to 4. So I have the inclination angle this time, and it was equal to 36, for example. I can find the x component. It's going to be simply equal to 5 multiplied by cosine of 36, and we will get a 4. It's going to be 4. If I want this one, which is the y component, I can say that it's the resultant force multiplied by sine of the angle. So simply, I can turn any vector that, if I have the inclination angle of any vector, I can turn it back into its x and y components. Now, that answers the question we just asked ourselves. How can I add two vectors if they were not right angle to each other? Well, this is done simply by finding the x component and the y component for each vector, then adding them together. So I put them in steps so you won't forget. If I were to find the resultant vector of two inclined vectors, knowing their magnitudes and the inclination angle, I will do the following. First of all, I will divide the two vectors into their x and y components using these equations. Fr is equal to cosine for the x component and Fr multiplied by sine for the y component. Second, I will add the x components together and I will add the y components together. Then it's like I went back to having two vectors with a right angle between them, and I will just use the Pythagorean theorem. Everything using an example will become much easier. So let's look at this example. Now, if I ask you to find the resultant vector and the inclination angle for these two vectors, the first vector, it's equal to 10 newtons and it has an inclination angle equal to 30 degrees. And the second vector, it's equal to 20 newtons and it has an inclination angle equal to 45 degrees. So let's graph it quickly. It will help. Let's imagine that we have this object and we have the first vector, which is equal to 10, and it has an inclination angle equal to 30 degrees. The other one is equal to 20 Newton and it has an inclination angle equal to 45 degrees. So it's going to be like this, 20 Newtons. And this angle this time it's going to be equal to 45 degrees. Okay, so the steps say that first thing, I have to turn these vectors back to their original components. So if I want to graph it again right here, let's start with the 10 Newtons with 30-degree inclination. It will be equal to F cosine of 30. In other words, it's equal to 10 multiplied by cosine of 30. And this one will be equal to 10 sine 30. So I turned back this vector into its x and y component. The answers are as following. For the x component, it's going to be 10 multiplied by cosine 30, as we mentioned, which is equal to 8.66 newtons. And for the y component of the first vector, it's going to be 10 multiplied by sine 30, which is equal to 5 newtons. So it was straightforward. Let's do the same for the second vector, which is equal to 20 newtons, and it has an inclination angle equal to 45 degrees. Well, for the x component, it's going to be equal to 20 multiplied by cosine of 45, which is equal to 14.14. And for the y component, it's going to be equal to 20 sine 45, which is equal to 14.14. Now, if I want to quickly graph it, I will have this shape like this. I will have a vector equal to 8.66, which is coming from the first vector. The other one is equal to 14.14. Now, I will have one going upwards, which is equal to 5, and another one which is equal to 14.14. Now, the first thing I must do, I must add these two together, and then I must add these two together. This will give us the following. If I add the x components together, it will be equal to 22.8, and if I add the y components together, it's going to be equal to 19.4. So let's graph it one more time. This is equal to 22.8, and this is equal to 19.4. So again, we went back to having two vectors with a 90-degree angle between them. And how do we solve it? How do we find the resultant vector for these two vectors? Simply, we will find the magnitude by using the Pythagorean theorem. So it's 22.8 squared plus 19.4 squared, and we will get an answer equal to 29.9 newtons. So let's graph it one more time. The vector is going to be equal, or the resultant force, or the resultant vector, it's going to be equal to 29.9. But what about the inclination angle? We need the inclination angle. Well, remember, let's draw this triangle right here. Remember that this is equal to 19.4, and this is equal to 22.8, and this is equal to 29.9. So if I need this angle, either I say it's equal to the cosine inverse of the 22.8 divided by 29.9, or it's sine inverse of the 19.4 divided by 29.9, etc. So I'm just using sine. So if we plug in the numbers, the answer is going to be sine inverse of the 19.44 divided by 29.9, which is equal to 40.5. So the inclination angle here, theta, it's simply equal to 40.55. Now, it takes some time, but with some practice, everything is going to be easy and clear. So if I want to add two vectors that are not right angled to each other, first of all, I need to find the x component and the y component for each of these vectors. I will add them together. Then I will go back to the Pythagorean theorem and using trigonometry to find the angle. Stay tuned in the next videos.